Hello, this is Miss Moore, and today during chemistry, we're going to continue our discussion on the simple gas laws, today focusing on calculations. So today's essential question, how are the gas laws used to predict the behavior of a gas? All right, here we go. So there are three different variables that can affect the behavior of a gas. There are actually four, but we're going to focus on the three, so we're just going to call it three variables. And as a reminder, variables are things that can change, and constants are things that do not change. So the four different variables, and let's change that since we're just talking about the three, let's just call this the three variables that will affect the behavior of gas are first pressure. And really important, you need to know the pressure units or at least be familiar with them. So the units are ATM or atmospheres, mmHg or millimeters mercury, PA, which is Pascal, kPa, kilopascal, PSI, pounds per square inch, and torr. Do something like box these in or highlight or something like that because you want to be able to go back and see this later, be able to find it in your notes. Okay, the second variable we're interested in is volume. And volume is the amount of space taken up by the particles. And the units for us are anything liters, milliliters, liters, centiliters, etc. Again, highlight this or something in your notes. And the last variable that we are interested is temperature. The units that we're using for gases is Kelvin, although sometimes the question will say degrees Celsius. And then this point is super important. All gas calculations must be done in Kelvin. Okay, or K. So if I give you a problem where I give you degrees Celsius instead of Kelvin, then you're going to use this to convert from Celsius to Kelvin. All right. So what we're going to do now is practice solving some problems. This is super, super important. Go through this, listen, really try to participate if at all possible. So the problem we're going to do is a gas has a pressure of 2.5 atm at 25 degrees Celsius. Calculate the pressure at 42 degrees Celsius. So we are going to use the simple gas law that we were working on with predictions. So P1 V1 over T1 equals P2 V2 over T2. And just like with predictions, we are going to identify which variables are in the problem. So here it looks like we have pressure. So here's pressure, and then it asks us for pressure. So we're going to be using the variable pressure. And then I see 25 degrees C, which I know is temperature. And that means we get to ignore the volume. All right. All we have to do now is put the numbers in the right location. Okay, so the very first thing we should do, though, before we do that, is convert our temperature. So if you remember, because it's in Celsius, right? So temperature in Kelvin equals temperature in degrees Celsius plus 273. So our Celsius is 25 plus 273. that is going to give us a temperature in Kelvin of, let's see, 298. So this one is 298 K. And we'll do the same thing for our second temperature. So temperature in Kelvin equals temperature in Celsius plus 273. And that gives us 315 K. So we'll call this 315 K. All right, so now that we know the temperatures, get rid of that, we're just going to plug stuff in. So our very first pressure is 2.5 atm. So I'm going to put that in, 2.5 atm. And then temperature goes below that. So we're going to use our, whoops, sorry about that, 298 K. And then our second pressure, it says calculate the pressure. So that's what we're trying to solve. Just like in math, when we don't know something, we're trying to solve something, we'll put our X there. And then our second temperature is 315 K. All right. So now we're in a situation where we have, what do we have? We have two fractions with an equal sign in between. So the way we deal with that is cross multiply. So I'm going to have 2.5 atm times 315K equals, we'll do the other side, cross multiply that way, that gives us 298K times X. So now we just need to solve for X. So I'll start by multiplying these two together. And if I did the calculations correctly, I got 787.5 atm K. And on this side, we still have 298 K times X. Now we need to get the X by itself. So what we'll do, being that 298 K X means we're multiplying 298K times X, we do the opposite of multiplying, which is dividing. So I'm going to divide both sides by 298K. That allows our K's to cross out. And when I calculate that, I got 2.6426, etc. atm. And I just want to keep two digits after the decimal. So the first number we're dropping is less than 5, so my final answer is 264 atm. So hopefully that's not too bad. All right, let's try another one. You should be writing down this problem, by the way. So this time we have 3.5 liters of a gas, has a pressure of 152 torr. If the pressure is decreased to 58 torr, what would the volume of the gas be? So let's start by writing our our simple gas law. We have P1 V1 over T1 equals P2 V2 over T2. And let's figure out what variables we have here. So it looks like we have pressure, right? So this is our pressure, our first pressure, and then our second pressure. So we're interested in pressure. And liters is a volume unit. So we have volume, and then how do we get the volume? Okay. So this time we're interested in pressure and volume, not temperature. So from here, we're just going to plug in our pressures and volumes as they are in our formula. So our first pressure is right here. It's 152 torr. Okay, and then let's see, our first volume is right here, 3.5 liters. And let's say our second pressure is 58 torr. And then it's asking us what is the volume, so that's going to be our X. So you'll note this time we don't have anything on the bottom. Like, I'm going to scroll up for a second. Like here, we set them up, one on the top, one on the bottom. We didn't do that this time because we're following what's here. And pressure and volume are next to each other. So from here, we're just going to solve. We don't even have to cross multiply. It's already set up. So if we multiply the left side, I got 532 torr times liters. And on the right side, we have 58 torr times X. All right. So to solve for X, we will divide 58 torr on both sides. Let's cross out, and that gives us, I got 9.1724 something, 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 liters. And again, we want to keep 2 digits after the decimal. So our final answer would be 9.17 liters. So hopefully you guys are doing okay. This isn't too bad. We're going to try one more. It's the most difficult one, but still not too bad. All right, last one. We have 5.2 liters of a gas has a pressure of 1.2 atm at 400 K. What is the pressure of the gas at 250 K and 3.4 liters? Make sure you're actually writing the problem down, so that way when you go back to refer to the math, you actually can see where it came from. All right, so we have our simple gas law again, P1 V1 over T1 equals P2 V2 over T2. And let's say what kind of variables we have this time. Well, L is volume, so I have 5.2 liters and 3.4 liters, so we definitely have volume we have to worry about. ATM is pressure, so we have pressure there, and then it asks us for the pressure, so we have pressure. And oh no, we also have K, which is our temperature. So this time, lucky us, we have to use all 3 variables. So we're just going to set them up exactly like they are in the problem. We're going to put the P times the V divided by T for the 1s and 2s. So my first pressure is 1.2 atm. And then my first volume is 5.2 liters. And then we have to do temperature as well, which is 400 K. All right, so we've done the 1s, same thing on the 2s. So our second pressure is 1.2 atm. And our second, wait a minute, anybody yelling at me, Miss Moore, that's not right. Try that again. Okay, so our second pressure is what they're looking for, right? So that is our X. Sorry about that. And then our second volume is 3.4 liters. And our second temperature is 250 K. All right. Now we are going to cross multiply. So we'll do those. I have 1.2 atm times 5.2 liters times 250 K. And we'll cross multiply these. And that gives me 400 K times X times 3.4 liters. Phew, got a lot going on here. All right. So multiply this side, and please, please be double checking me. I happen to make lots of calculator mistakes. All right, I got 1,560 atm liters K. And we'll multiply this side. And I got 1,360 K liters times X. All right. We're almost done. We want to get the X by itself, so we're going to divide both sides by 1,360 liters K. And that crosses those out. And when we divide, I got 1.14705, etc. ATM. We want only 2 digits after the decimal. The 7 is bigger than 5, which means we're going to round up. So final answer is 1.15 ATM. Okay, so hopefully this isn't too bad. You just need to read the problem, identify what is your pressure, volume, temperature, whatever, plug it in to the simple gas law, P1, V1, T1, P2, V2, T2, and solve for X. All right, that's it for today. Have a good one.